welcome to our RAP program Leads Coffee and Connect meeting. And this webinar will showcase the EuroRAP Great Britain program led by Road Safety Foundation in partnership with local partners. So thanks for taking the time and join us today. Just next, my name is Alessandra Francois. I'm the Training and Accreditation Coordinator at iRAP, and I'll be your moderator today. So just a little bit of housekeeping for our session today. Our webinar will have 90 minutes, including time for questions. This session is being recorded, and we'll send the files, the video and the presentation files to you tomorrow. You'll receive an email with the link to access these files. And all attendees are muted, but you are welcome to post your questions on our chat at any time. You see probably in your control panel, you have something very similar to what you see on the screen now. So just post your questions on the tab, and after each presentation, we'll stop to answer them. And now, again, I will hand over to Judy, who will talk a little bit about what we'll see today. She is the iRAP Global Program Manager. So the mic is yours now, Judy.
Thank you, everyone, for joining the second Coffee and Connect session for our RAPs around the world. Our goal for these sessions is to bring you together, to share ideas and resources, to learn from one another, and to develop friendships for support as we share this journey. I encourage you to ask questions today or in follow-up after the session to make the most of what you see and hear. It's a pleasure today to profile the EuroRAP UK program because it's one of our global best. It's an exemplar of assessment and performance tracking success over 20 years. Every year, 54,000 kilometres are risk mapped and performance tracked with the support of Ageas Insurance UK. They engage partners really effectively, involving everyone from the road authorities to investment funds and insurers, engineering firms and technical innovators, research agencies, policymakers, the road safety NGOs, and especially the community who travel the roads. They've done a brilliant job, one of the best I've seen, in innovatively communicating results, turning them into simple tools to inform investment and to drive advocacy. The policy target to achieve 90% of travel on the strategic road network at a 3-star or better safety standard by 2020 has been met. And so now it's time to set the new indicator for the next decade. Results at the roadside really do speak for themselves. Upgraded roads have been achieved through strategic investment with the £100 million Safer Roads Fund. And they innovate. EuroRAP was the earliest RAP, helping to lay the foundation for the methodology and resources of iRAP. The UK program continues to lead with innovation in urban research, road design, and tool enhancements. Today really is a rare opportunity to hear from this UK program and the key players who are making a difference. At the end of each Coffee and Connect, we share a survey to gauge your feedback and ideas for future sessions. This forum is for you, so we're very keen to shape it to your needs. Feedback from the November session indicated that some of your greatest challenges are stakeholder engagement, integrating programs into existing government frameworks, and accessing funding. You really liked the iRAP resources and updates shared and asked for more case studies of success from which you can learn from the guidance, experience, and the produced resources of others. The UK program is a sterling example for all of this. So without further ado, I hope you've got your coffee in hand, and I hand over to RSF Executive Director, Susie Charman, and our presenters today. Enjoy. Thanks, Susie.
Hi, and thank you so much, Judy, for the introduction. I'm just going to give you a very brief introduction now to the Road Safety Foundation and our programme, and to tell you about the agenda today that will give you a brief snapshot of the work that we do. So the Road Safety Foundation is a charity in the UK established in 1986 as the AA Foundation for Road Safety Research, and we became the Road Safety Foundation in 2007. We were a founding partner along with some of the other European programmes of EuroRAP, and we were key to developing iRAP. Our programme is wide and varied, and it started really with crash risk mapping, which we've done annually since 2002. We also undertake star rating work with both local and national road authorities. We undertake research to do with policy setting, looking at governance and funding arrangements for local and national road authorities. We also have a few other strains of our work, which include roads that cars can read, making sure that roads are prepared for increasing levels of autonomous vehicles, the Older Drivers Task Force, safe system training, and also supporting knowledge transfer overseas. We also have a research and innovation strand to our work, looking at urban road safety measures and an evaluation of the emergency active travel facilities that were put in place during the COVID-19 pandemic here in the UK. So our agenda today is pretty full, so we're going to be giving you an overview of each of these topics rather than the full detail. And if you want some more detail, do please get in touch, and we're very pleased to share further information. I'm going to start off with Brian Norton, who is the Research and Programme Manager at Rosaki Foundation. He'll be covering our crash risk mapping programme. Then I will be taking over and talking about DFT's Safer Roads Fund. Then I'll be handing over to Jeremy Phillips from Highways England and John Fletcher from TRL, who will be looking at Highways England's network-wide survey and performance indicators programme. Then Kate Fuller and Monica Olisaigas will be talking about the Road Safety Trust urban research and tool enhancement work that they're doing. Following on from that, we'll have Sam Hanson from Warwickshire County Council. He'll be telling us about a route review that they've done in Warwickshire. Sam Chapman from the Flow will be talking about using telematics speed data in iRAP surveys. And then finally, James Bradford from iRAP and Chris Fino from iRAP will be talking about the star rating for designs process. So without further ado, I shall hand over to Brian Norton from Rosaki Foundation, who is talking about crash risk mapping. Over to you, Brian.
Thank you. Can you hear me? Can someone indicate they can hear me?
Yes, yeah. Brian.
Hurrah. Hurrah. We're not completely beset with technical problems. Thank you for the introduction, Susie. Good afternoon, everybody. Before I get into crash risk mapping itself, let me start with some context about Britain's road safety performance. Last year, as Susie mentioned, we actually reached 20 years of crash risk mapping results in Britain. This graph shows the number of fatalities per million people in various countries over the last 20 years. We've calculated them as 5-year rolling averages. The red line here, or it might appear as orange on some screens, represents the UK's figures. 20 years ago, as you can see, the UK had one of the lowest numbers of road deaths per head anywhere in the world at 54 per million people. And this has fallen by almost half over the last 20 years to around 28 per million people. Various countries, though, have been catching up with the UK. Spain and Slovenia, shown in yellow and blue respectively, have substantially reduced the gap, and the number of road deaths per head in Ireland, shown in green here, has more than halved. Norway, at the bottom of the graph, has improved from around the same level as the UK at the turn of the century, to now be the clear frontrunner. Despite the improved record, the UK has fallen back to being amongst the chasing pack. Coming on to the constituent countries of the United Kingdom, we see Northern Ireland here in green, almost catching up with the rest of the UK. England in red remains ahead, or below, I suppose, ahead of Scotland in blue and Wales in yellow. However, since 2010, the number of people killed on roads in Scotland has fallen by almost a quarter, compared with just a 2% reduction in England. We now come on to crash risk mapping itself. Next slide, thank you. Our crash risk maps indicate the number of fatal and serious crashes per vehicle kilometre, so what we call the individual road user risk, split into 5 bands as shown here. They range from the lowest risk routes in green, such as part of the M5 displayed here, through yellow, orange and red to the highest risk roads shown in black. Altogether, we have around 4,000 routes in our analysis, and we're covering all of Britain's motorways and A roads now. Next slide, please. Our network's actually evolved quite substantially over the last 20 years. Many routes have been merged or split, or in some cases both, to ensure that they better reflect the layout, the way in which they're commonly used, and also that our results remain statistically robust. Nonetheless, more than 400 of our routes, with a total length of around 13,000 kilometres, are broadly the same routes as they were 20 years ago. On these routes, the number of fatal and serious crashes has reduced by almost a third, despite traffic on them increasing by more than half. Here's an extract showing the differences between the results for this comparable network for the two time periods almost 20 years apart, using the same bandings for both time periods. Next slide, please. Packaging up the lengths of roads of each banding on this comparable network, 20 years ago, high-risk roads alone, shown in black here, accounted for 8% of road length. Today, only 1% of roads now remain high risk, and only a further 5% are now in the medium high risk group, shown in red. There's now almost 4 times the length of low risk road, shown in green, compared with 20 years ago, with a further increase in the length of low to medium risk roads, shown in yellow. This improvement is consistent across most road types, and more than half of the comparable network has improved by at least one band over the last 20 years. Moving on to last year's full results, as opposed to just that comparable network, this is an extract from the full map from the report, which is available in the library on our website. Although the motorway and A road network represents only around 13% of Britain's road length, it accounts for some 60% of road deaths. You can actually access an interactive version of the map produced by our friends at Agilicis via our website, roadsafetyfoundation.org. You just go to Tools and then the Crash Risk Mapping Data Portal, or you can just go to rsfmaps.agilicis.co.uk, which should, there it is. Thanks, Susie. Here you can also find what we call crash density maps, which indicate the collective risk as opposed to the individual risk. Again, our routes are split into 5 different bands. Next slide, please. Even under ordinary circumstances, there's a compelling case for road safety infrastructure investment because of the high cost to society of road crashes, some £36 billion every year. We face unprecedented times as we seek to rebuild the economy and manage the COVID-19 pandemic, and investing in infrastructure can help with this. Safety remedial schemes are often quick to plan and implement. They give good economic returns and can be targeted to help level up and to increase employment. Facilitating active travel is also important, and road improvements can also help to reap the benefits of advanced driver assistance systems and, in the longer term, of connected and autonomous vehicles. Last year, next slide please, we subsequently outlined an investment portfolio for strategic, major and other local authority A roads. Again, this map can be found via our online tools. The investment packages we identified were based on a number of detailed assumptions described in our report. Next slide, please. We estimated that around £1.2 billion of investment across 5,000 kilometres of road in England, Scotland and Wales could prevent more than 8,000 fatal and serious injuries over the next 20 years, with an average benefit cost ratio of 3.6. I think that's it from me, Susie. Back to you.
Thanks, Brian. We don't have any questions now, but I just want to highlight to our attendees that they can post questions on our chat, and then we'll stop after each presentation to answer them. Thanks, Brian. And Susie, the floor and screen is yours.
Thank you. So I'm going to be talking to you today about the Department for Transport's Safer Roads Fund. So the DfT Safer Roads Fund was a £100 million investment for England's 50 highest risk local authority A road sections in England. So that's some 700 kilometres of roads. The fund was non-competitive, which was really important for our local authority partners, because what they can find is they can spend a lot of time and effort putting in bids to competitive funds and being unsuccessful, and where their resources in terms of personnel are so stretched, it's really, really important that they know that there's going to be some funding at the end of their efforts. These 50 highest risk local authority A road sections were identified from our crash risk mapping work that Brian has described, and they were based on individual risk. So the routes were 50 routes, but covered 30 road authorities. So it was quite a spread of routes across England, and you can see what the locations of those on the map on the left-hand side of your screen. The Safer Roads Fund was announced in November 2016. The Road Safety Foundation was mobilised to support local authorities at the end of February 2017, and local authorities were asked to submit their applications to the Safer Roads Fund in April and September 2017, so in quite quick timing. The schemes have been built over the last 4 years, with the last ones just nearing completion now. The aim of the fund was to reduce fatal and serious injuries on these routes, but also to facilitate a culture change. So building capacity for safe system delivery and introducing a new approach to road safety risk management and treatment through the iRAP star rating approach, and also to encourage collaboration both locally and nationally. There were some enormous challenges, not least because the Road Safety Foundation at the time only had 1 member of staff, and that was me, and I was working part-time. There were 50 sections across 30 authorities, none of whom had applied iRAP before, apart from West Sussex. So really, really a new technique that we were introducing to England. Authorities wanted to apply their own knowledge and their local practice and approach to the iRAP Safer Roads Investment Plan. And the tight timescales meant that there would be an awful lot of scenarios to model in no time at all. When we started to look at the Safer Roads Fund application process, we realised that given that there were 2 times where the local authorities could actually put in their proposals in April and September, we knew that most of the local authorities would probably submit in September, and that because of the timing of the summer holidays, we would probably end up with an awful lot of activity just before the September deadline. So we knew that we would be unable to really use the standard way that we model scenarios in the iRAP tools. So it would be very difficult to keep running through different investment plan scenarios for them right at the last minute when they were all coming in thick and fast and just ready for that submission deadline. So we created a new approach with James Bradford from iRAP. And the new approach we called a UDIP, a user-defined investment plan. And we tried to find a way of operationalizing the need to run different scenarios to test the potential impact, safety impact of different treatments without having to manually go into VEDA and create new coding scenarios each time. We just wouldn't have been able to support all of the requests that we were going to get, and we needed a record of what was actually put into each planned treatment scenario. So here what we did was we asked our local authority partners to review the risk on each of the routes, so using the interfaces within VEDA, which I'm sure you're all very familiar with. So on the left we've got the crash risk worm by by crash type, and on the right we used a GIS tool with our coding partners FPZ, where we effectively presented through the recommendations from in terms of countermeasures, and presented those in the GIS system, so that on each change as you hover above the blob, if you like, you get all of the final Safer Roads Investment Plan countermeasures for that 100-metre location, as well as all of the overridden ones as well, so that the road authorities could look at the video see what the model was suggesting for that location, and go through and design their own locally appropriate and practicable and feasible measures at each individual location. What we then asked them to do was to record their what they wanted to implement in terms of their bid to the Safer Roads Fund into a colourful spreadsheet. And here you can see the countermeasures on the left-hand side go down. I haven't got all of them in there because you couldn't fit them all into one slide, but of them, all 90 countermeasures are in the spreadsheet, and then you've got chainage across the top there. And for each 100-metre location, we have the measures that were included in the Safer Roads investment plan in green. We have the overridden measures in sort of amber colour, and then all we asked them to do was to record where they wanted to implement a treatment by putting an F in the cell that corresponded to the location and the treatment, and that turned the bits that they were actually going to implement into a red colour. Now, there's an amazing process that James Bradford developed in order to enable us to then put that back through VIDA and then create a new UDIP, a user-defined investment plan. And the user-defined investment plan looks just like the Safer Roads investment plan, but it's just simply the countermeasures that the road authority wanted to implement at each location along the route, rather than everything that the model was suggesting. So here, yeah, you can see it's exactly the same as the Safer Roads investment plan, where we've got the countermeasures, the length, the FSI saved, the present value of safety benefits, the estimated cost of those measures, and then the programme BCR. In reality, the Department for Transport needed a bit more detail from local authorities in terms of the investment case that was necessary. But the really difficult bit for the local authorities would be the estimation of the fatal and serious injuries saved for their set of countermeasures that they were wanting to implement. So the fatal and serious injury estimates were absolutely key in terms of road safety impact assessment. The DFT also asked them to look at where they would expect to have slight casualty savings as well. So we used a ratio-based approach to estimate the number of slights that we would expect. And they wanted things like operating costs, traffic delay costs, and very accurate build costs, obviously, more accurately you could model in the iRAP system to be presented in, to really complete the economic case for investment. There were lots more forms and guidance that were developed by DFT and ourselves for this process, and obviously it'd be possible to ask DFT if we could share them with any country that would like to look at doing something similar in the future. In terms of those schemes, we ended up with 49 of those 50 routes with a scheme, and those are all described in a report that's on our website. And if you'd like to be pointed towards that, then do please let me know. For each scheme, we displayed the capital spend investment that was required, and this example is from Calderdale, which is up in the north of England. We estimate that there'd be 51 fatal and serious injuries prevented over 20 years, the net present value being £20.6 million, the economic cost over 20 years being 2.7 million, once you add in operating costs as well into the picture. And the overall benefit cost ratio for the scheme 7.6. And the measures included some pedestrian crossings, some pedal cycle facilities, 6 improved junctions, 4.5 miles of improved roadside shoulders, 4 miles of cleared or protected roadsides, 12 improved bends, 1 mile of improved medians, and 3 miles of improved road surfaces. And we created these maps to show at a very brief glance the sorts of measures that were being implemented. And so we had safer roadsides in one colour, safer pedestrians and cyclists in another colour, so you could quite quickly discern what sort of schemes were being implemented as part of the Safer Roads Fund. Another example is from Kent, the A252, and we've got some nice pictures of the before and afters here. So you can see on the left-hand side, this is a place called Chilham in Kent, where there was central hatching, delineation, shoulder rumble strips, runoff sealing, rehabilitation and speed limit reduction implemented. You can see before and after. And then the Charing Hill example, where they removed an overtaking lane and put in some wide central hatching and delineation to hopefully reduce some vehicle speeds there. Together, that £100 million investment from Department for Transport has allowed local authorities to put into place 290 miles of improved roadside shoulders, measures like raised rib edge lines or shoulder rumble strips, 135 new or improved pedestrian crossings, 225 improved junctions, 300 safer bends, and the list goes on. This really is a game changer for these high-risk routes. And together, the results that we expect the Safer Roads Fund to achieve are very impressive, with that £100 million investment estimated to prevent 1,450 fatal and serious injuries over the next 20 years, with a value of prevention of 550 million. When you compare the whole life cost of those measures against the value of prevention, you generate a portfolio benefit cost ratio of 4.4, so £4.40 back for every £1 invested. This means that such investments really stack up against other major transport projects. Arguably, they should be appraised and seen side by side with bypasses and other major schemes. It gave us the evidence base really to make that case, that we do annually through our crash risk mapping work as well, that these road safety rehabilitation projects are really highly effective, and they really need to be considered alongside other transport schemes. The Department for Transport also initiated an independent evaluation by Kantar Public, and it's a process-based evaluation based on interviews and case studies. Generally, the Safer Roads Fund was received very well, and they really liked the road safety engineering support that we were able to give them, and they liked the proactive iRAP approach. Well, I say they liked it. It was embraced by most. Still, it's quite an alternative approach for some more traditional road safety engineers here in England. But for the most part, it was embraced really, really well. They liked the guidance, the training, and the Department for Transport support and the VIDA software. There were, however, some issues. The selection of priority routes was a little bit challenging. So if you remember, those 50 routes were selected through the annual crash risk mapping work that we do. And actually, it seems that selecting those routes purely on the basis of individual risk was probably could have been improved, shall we say. What we ended up with were some routes that were incredibly low flow, so it was very difficult, though not impossible, to develop really high return programs. So it means that we fed that back into our annual crash risk mapping work, where we now present that investment map that Brian showed earlier, which is a much more robust manner to find the best value schemes that can possibly be implemented out there. And if anybody wants to talk about that more, then we can do so in more detail. There was also a huge pressure in terms of time for bidding and the resource impact for local authorities trying to work up their proposals in such a short period of time. They also felt that the UDIP process was absolutely brilliant and really revolutionary for us here in the UK. That really needed to be embedded within the iRAP tools themselves. So instead of having to go out to a different screen and use a spreadsheet and update those cells by making them turn red and remodeling it through offline, it would be much better if that was part of the iRAP toolkit itself. They also worried, local authorities worried a lot about whether their exposure to iRAP would really be beneficial in the long run, whilst their funding situation was so tight. Here in the UK, we are finding our local authority budgets reducing. So there's very little left. So they were worried that they wouldn't necessarily, although they liked the proactive approach, they wouldn't necessarily be able to apply it in the future because there just wasn't the source of funding available. So that's again why we tend to, through our crash risk mapping work every year, we're continually asking that for there to be another round of the Safer Roads Fund. And there will be more evaluation to follow as well coming out of this, a data-based evaluation, and also there will be re-star rating all of the routes involved. So given that the UDIP process was really successful, but it's actually quite tricky to apply because there are lots of different places to go and different spreadsheets to look at, what we're hoping is that later in 2021, there will be a route review tool made available, possibly in VIDA, we're not sure yet, but it would allow local authorities and other road authorities to review key information in one place, so road images, the fatality one by crash type and the like, and the coding that underpins the iRAP assessment, and also the recommended and overridden countermeasures. And the hope is that we'll be able to produce a system that will allow the user to be able to click on and click off countermeasures interactively and model scenarios more easily without having to go back into the core coding files and update those to model scenarios. This hopefully will put the power back in the hands of the road authority and the road safety engineers, allowing them to tailor their Safer Roads investment plan to suit local conditions, permissible measures, and what's feasible, and also, importantly, what they can achieve within their budget. Any questions?
Yes, Susie, it's a big question here, but we have two questions. I saw the funding for Safer Road is quite high compared to developing country like Indonesia. Do you have any suggestion on how developing country can focus on applying countermeasures and iRAP method with limited funding?
Yeah, I think it's all about, first of all, there are two things. The first thing is to try and find increased funds because the investment stacks up. So I would always say that we shouldn't have our ambition diminished because of available budget, because the economic returns from road safety measures are extremely high. So we've just got to find our right mechanisms, and that might be through development banks, it might be through performance bonds, it might be through all kinds of different innovative methodologies. So that's the one thing, is that we shouldn't just always continue within the same envelope that we've always been stuck with. The second is that there are lots and lots of these measures that can be incredibly low cost. They can be embedded within maintenance regimes. So a lot of the measures that were put in here were about signing and lining and marking and shoulder rumble strips and the like, which are relatively low cost to implement. So I think that it's about also then trying to find your other ways of getting that spend accommodated within existing budgets as well. So within maintenance regime budgets, for example.
And the other question is how other countries might replicate your experience in UK. So how they can start? What could be the first step towards this? It's very similar question, but a good experience.
So I think there is an opportunity to for us to advocate more widely for something like the Safer Roads Fund to be put in place by other departments for transport in different countries, and to talk about the successes of the Safer Roads Fund so that others might follow suit. We obviously have a huge amount of learning because this was not without some challenges as I've outlined. So we've got a lot of learning behind us. We know where the pitfalls are. We know what works and what doesn't work. And I think there's an opportunity to go to government and say, actually, a Safer Roads Fund, really can stack up as an investment for you. And we can help you do that if you want to have more detail, if you want to learn more about the process, if you want to have access to some of the forms and the reports and so on. I'd be really pleased to work with you to see if we can try and make that case to your governments.
Thank you. I think we can move on to our next presenter. Thanks, Susie. And next slide, please. And our next presentation is with Jeremy Phillips, Highways England, and John Fletcher, presenting Highways England Network Wide Survey and Performance Indicators. The mic is yours, Jeremy. Thanks.
Thank you, and thanks for the invitation to join you today. It's a real pleasure to be here. Highways England's had a really close relationship with iRAP and the Road Safety Foundation now for some years. And over the next few minutes, I just want to give you a very brief and general overview of our road safety vision, where the star ratings process fits into that right now, and how I see it supporting our long-term ambitions over the next 5 to 20 years. And immediately following me, John Fletcher from the Transport Research Laboratory will follow me with a detailed description of our work in this area. Now, if I can have the next slide, please. To put this into some context, I think it's worth me mentioning that Highways England has actually got 3 tiers of casualty reduction targets and goals. So the first one is a target to reduce the numbers of those killed or seriously injured by half by 2025. That's against a 2005 to 2009 baseline average. The second tier is a Vision Zero goal in which no one will be killed or seriously injured on our network by 2040. But thirdly, we actually go beyond Vision Zero with a long-term ambition that no harm of any severity will come to anyone as a result of them travelling or working on our roads. And to support us in tracking progress towards those goals, we've got a number of performance indicators in place, one of which relates to the percentage of travel on 3-star or above roads. The current target is 90% of travel by 2020, and that's currently being reviewed and reset for 2025. Highways England's also adopted a safe systems approach in common with many other highway authorities, and we're going to use that to attain our goals, and iRAP forms part of our response to the challenge of delivering safe roads and roadsides within the safe system. Next slide, please. Thanks. We've invested heavily really in the principles of the iRAP approach since version 1, and we've taken an active interest and a role in developing the process. More recently, that's included the development of the Shunt model, which John will expand on a little later. Now, our original baseline for improving network performance goes back to the 2010 to 2015 period, and that formed part of the basis of our most recent target of 90% travel on 3-star or better roads by 2020. The network review is still ongoing, but our forecast outturn is that we will have exceeded our target with around 95% of travel, which is good, but it still means that we have road users routinely using 1- and 2-star roads on a high-speed strategic network. So there is clearly a lot more work that needs to be done. Next slide, please. So what's happening right now? Well, we're currently modeling how the network is likely to look by 2025 so that we can reset our targets for further improvement. Also, casualty and severity reduction scheme proposals, the ones that come in from our regional engineers, are assessed in part against their likely contribution either to consolidating or improving the star rating of a route. And this will become a much more rigorous process in future, when we'll expect design proposals to be put through the VIDA model to ensure that final designs are the best possible fit with our ambitions for safe roads and roadsides. And as our future targets will be set against a baseline that was refreshed, slightly annoyingly, during the height of the pandemic last year, we're also modeling the effect of COVID on the network during the assessment period and the likely long-term impact of both the pandemic and the potential economic recession that's going to result over the next roads investment period up to 2025. Next slide, please. So just to summarize, for the next few years, we'll re-establish our baseline this year and forecast the condition of the network through to 2025. Now that's going to allow us to set new targets, and those targets we know are going to be much more demanding as they're based on a more demanding assessment model. And in recognition of that, we're developing a new program of training and support to help safety engineers and designers to use the VIDA tools that they're going to need to meet our expectations for safe highway design. At this point, I'd like to hand over to John for a more detailed appraisal of our activity. John?
Hi, Jeremy. Can people hear me? Yeah.
Yes.
Yes.
Great. Yeah, thanks again for the opportunity to be involved in this session. I think it's really, really useful. I had notes written in Microsoft Word. It's just decided to update itself, but I'll carry on. Brilliant. You can't beat technology. So I'm John Fletcher. I lead the iRAP Centre of Excellence for the UK, which is based at TRL. So I've been involved with iRAP for more than 15 years now, and TRL itself has been involved even longer, working with RSF, the iRAP, back to EuroRAP, to develop the range of protocols that we've been hearing about. And this really is some of the most innovative improvements that provision of new tools for people involved in managing infrastructure safety on the network, on road networks, that's going on, and it's great. It's really great to be a part of that. Really leading on from what Jeremy said, there's been a major program of applying iRAP to the strategic road network, the trunk road network, or the main road network that Highways England are manage, and this has really provided a really good opportunity to make some changes to the iRAP global star rating tool. So these range from what are, I would call, tweaks or smaller adjustments and changes, but also more major changes. The fact that Highways England are funding a longer term program is really fantastic, because it has given TRL the opportunity to work and make these changes, but also there's the opportunity to field test them. So the latest program started in about 2015, and that was about star rating, benchmarking Highways England's network using new models. We'd also helped Highways agencies, it was then, to star rate the network in 2010. And currently we're involved with RSF and Highways England to recode the network for 2020. But that has provided a fantastic opportunity to develop these changes, but also then to test them. It's really important to test them. They should be going into the network, into the iRAP main model, which will be used globally. And the fact that it's basically one model used globally is a real strength of star rating. It enables comparisons to be made between different networks, and it's really useful. So some of the more minor things that we're doing, nevertheless important, are to look at the features that were on the strategic road network, which weren't represented particularly well by the current codes available for doing the coding, which eventually goes into the model and then generates the star rating, and on which the base, these strips and other aspects are based. So on dual carriageways, there's still some median gaps present. So the way that median gaps are represented in the model at the moment basically assumes that they're there on purpose in an urban environment as a sort of U-turn facility. But you can see the kind of junctions we've got on the photograph on the right-hand side, and they're not really about using them as U-turns. Also, we noticed that because roundabouts are at the start and the end of iRAP sections, there can be some inconsistencies in the way that they are coded, and we just wanted to clear that up. And also, there are things like staggering a junction, so taking crossroads and basically turning it into two T-junctions. the risk improvement wasn't being represented in the model, and that's something that's been done quite significantly across the SRN. So they're the more sort of minor tweaks. But we also wanted to formalize aspects of the coding process. So we, at the moment, where there are speed cameras, which we know are really effective, average speed cameras over long stretches and fixed speed cameras at points, we investigated the impact and the effect that these have on crashes afterwards from real world studies. But also we wanted to improve the way that they're coded in the system, as they were just put into the notes and then coded in retrospectively with changes to the speeds that went into the model. So we've come up with ways to more formalize the way they're coded. The more major change, and probably potentially the most major change to the main model in recent times, is the development of what we call the Shunts or ITS module. At the moment, vehicle shunts are not actually modeled. They go into this category called vehicle along. And the reason for this is that the countermeasures for shunt crashes are not standard infrastructure engineering solutions, but they're more ITS based. So that's things like we have the MIDAS technology in the UK, which is a queue protection. So they warn you that there's stationary or slow traffic up ahead through warning systems to moderate your speed, for example, but also variable speed limits, which are being employed on things like smart motorway. And these are not, they're ITS rather than classic infrastructure systems. So we have developed a module, and because of this longer term commitment of Highways England to the recent program, we're currently coming to the end of recoding the network for 2020, but we've done that in a way that has enabled us to incorporate and test these features. And it's really important that we understand that they work in the real world and they produce the kind of inputs and to the iRAP system that are useful for end users. So I will leave it there. Really happy to hear any questions. Thank you.
John, we have one question that was for Susie, but maybe you can share also your experience there. So how the funding agencies in European countries perceive the validity of the RAP methodology in calculating the ROI or BCR, or are they involved in any committee within EuroRAP?
I'm not so sure. We are members of EuroRAP, but I haven't been so involved. The validity of the model is really interesting and really important. Certainly there's work in Australia that shows that the cost crashes relates to the star rating in the way that you would expect, that on high risk roads, the cost per unit, the cost of the crashes per unit traveled is higher for 1 star than lower for 2, 3, 4, and 5. We've done work with Highways England from 2015 to check that the KSI, killed and seriously injured crash rates coincide with the risk that's calculated by star rating. And then on the basic, the way that the cost benefits are worked out, it's in a very common sense way and based on internationally accepted data. So the risk factors relate to the kind of before and after impacts that we know changing features has on the network. So that basically iRAP is really relying on the traditional approaches to some extent, that you can use to develop a scheme without using iRAP, except that it's based on risk. And that is a leap. I think Susie was saying that some people have some reservations about iRAP, but it's really about moving from managing reactively, the crashes that occur and saying, okay, I think I've got a problem here, to managing whole networks in a more coherent way, which is working on risk. I mean, you get crashes because you subject flow to risks on the network. So it's much better to manage risk. It's more safe systems aligned and it's proactive. So I think the answer was in there somewhere.
Okay, so just one more question. And do you want to? Okay, I'll just ask one more question on your presentation. That Willie is working on currently doing research on strategic road network in the UK. He's saying, I understand the safe system have been put in place along with star rating system. In your opinion, how important is it, the star rating system, to be perceived by road users in general? I saw a promotional safety campaign on go left when your car breaks down, something like that. Yeah. Which is, yeah.
I think it aligned with what Jeremy was saying. iRAP is really, it's a safe system based tool. So it acts on KSIs. It looks at vulnerable road users as well as vehicle occupant safety, which is really, really important. And it incorporates those this idea of working with risk rather than retrospectively with crashes. So it's so heavily safe systems based that, and I mean, safe systems is really, it's about spending more money, but doing that in a very coordinated way. And that for me is why, iRAP's so important, because it's risk based, but it also, there are other aspects that need to be pursued as well as iRAP. But it's really the most safe system way that you can approach engineering safety, infrastructure safety at the present time. I don't know, Susie, do you want to jump in?
Yeah, I've just got some helicopters going ahead. The noise. Just hopping back to the question about whether this is an acceptable approach now, and I think really we have to face reality that we have to move to a proactive system for assessing risk, because we're starting to get our crashes are so distributed across the network. So taking a purely reactive approach is not giving us the advances that we need to meet the objective of reducing deaths in the speed that Jeremy needs them to be reduced to meet Highways England's targets. So we have to proactively address risk. I think with the Department for Transport adopting this approach for the Safe Roads Fund, that gives us that assurance of legitimacy, if you like. In terms of the benefit cost ratio calculations, as I mentioned earlier in my presentation, they did make that more detailed and more kind of in line with their own sort of economic processes, but they use the fatal and serious injury reduction to drive all of that, because that's the bit that they would find very difficult to do without the iRAP model. The rest of it, you can include things like journey time delays and other bits and bobs that others might like to include in the economic appraisal, but it's the fatal and serious injury reduction bit that iRAP uniquely brings to the table. So the truth is that the iRAP outputs can fit into other systems if necessary, but also stands alone as a pretty good system. If there isn't another system in place, as John said, it's in accordance with international good practice. I don't know if Jeremy wants to come in on any of the questions asked as well.
I'll just say you can't really manage network safety on the basis of KSIs or injury crashes. Really, it should be based on risk. I mean, the reactive approach is better for hotspots and small discrete areas, not whole networks. Sorry, Jeremy.
Not at all, not at all. But I think there was an element of the question about the extent to which the public understand what iRAP delivers and what the SAFE system delivers. And I think there's a great deal of work still to be done in that area. I don't think there's a very clear understanding amongst our road users about what we're trying to achieve in terms of SAFE system, and some of the methodologies like the star rating approach, and like iRAP as to how we're going to deliver some of the aspects of the system. And one of the ways in which I would illustrate the extent to which there's a disconnect between the work that we're doing in these areas and our approaches and the public's understanding of all of that is that the public, our road users, very clearly don't understand their role within the system. So at the moment, our customers, I think, would be forgiven for thinking that they were passive within the system, that they were receivers of the service, but actually they should be active components. And the extent to which they don't understand how much and how important it is for them to be active participants in the system tells me that they don't really understand the system itself or how it operates, and certainly not individual components like iRAP and star ratings. So much more work to be done in that space.
Thank you. I think we will have to move on. We have more questions, but I think we'll be able to answer later or post on our website. Thanks, John. And our next presenter is Kate Fuller and Monica Willislager. Kate Fuller is from Road Safety Foundation, and Monica Willislager is from iRAP. They will present Road Safety Trust, Urban Research and Tool Enhancement. The mic is yours, Kate.
Many thanks, Ali, and good afternoon, everyone. Next slide, please. Thank you. In December 2019, the Road Safety Trust awarded the Road Safety Foundation funding to undertake a project to review best practice across the world with regard to vulnerable road users and improve the Safer Roads investment plans within iRAP's Reader tool to ensure the latest thinking and innovation was reflected for vulnerable road users in an urban environment. The overall objective of the project is to help road authorities to better make the case for investment to prevent vulnerable road user fatal and serious injuries. Next slide, please. The project commenced on the 3rd of February 2020 and consists of 5 work packages alongside project and technical management, with the work package of the pilot trial being shown as 2 activities in the graphic. The first work package was to define the need, which involved discussing with the steering group of local authorities what they felt was needed. And work package 2 was to review existing literature and standards to consider the effectiveness of urban vulnerable road user treatments in different scenarios. Following this review was work package 3, which is specifying and developing urban strip tools. Based on the first 2 work packages, a list of urban safety measures will be developed and categorized according to the evidence base available to substantiate the countermeasures risk modification factor. Those found to be relevant and with an adequate evidence base will be included in the refreshed iRAP tools, which will be developed to become an integral part of iRAP's online tools. This work is due to be completed in October 2021. Once this work is complete, work package 4 will be a pilot trial. 3 local authorities will conduct an iRAP survey of a sample of urban routes. These will then be coded by an accredited iRAP coding team, and a script will be generated for review. The local authorities will provide feedback on how useful and locally appropriate these investment plans may be, determining their suitability in relation to local policy. The final work package is disseminating findings and advocacy, including training sessions at the end of the project to be held for practitioners. And dissemination will continue at various conferences and through future training sessions delivered by the global iRAP team. Because we're short of time, I'm going to hand over to Monica now to discuss this strip in more detail.
Thank you, Kate. I apologize, everyone. I'm not able to turn my video on. But my name is Monica Willislager. I'm based in Guangzhou, China, and I'm iRAP's Global Innovation Manager and Safe City Specialist. And I've been working with RSF on this project. As Kate said, we're really only partway through. We've completed the literature review of best practice and made several recommendations now. But I just wanted to touch on a little bit of background. just to help contextualize what it is we've done and what we're trying to achieve, and where we're currently at in the project. So basically, as most of you would know, our star rating FSI estimation models include 4 road usage types, and that involves 12 crash types. Safe road investment plans list 94 different countermeasures or safety treatments for roads, depending on the attributes that are recorded in star rating assessments. And for each countermeasure, there's up to 2 outcomes that can happen. So this is done for every 100-metre segment of road, and are prompted by the attributes recorded. So for instance, if there's a roadside hazard, that's a tree that's recorded, a countermeasure that could come back from that is a roadside barrier. These are the sort of things we're looking at. This project really focuses on the bicyclist and pedestrian crash types. And so you can see there that the sort of things and the risks that would come out of that. So what we've done is we've gone and reviewed a whole range of different best practice guides, specifications from the UK and abroad. Susie, can you switch to the next slide, please? And from that, we've come up with 9 different recommendations. Next slide, please. Thanks. So there's a number of different measures here to do with how we better tailor the Safe Road Investment Plan for the needs of vulnerable road users, specifically pedestrians and bicyclists, and really focusing on quite a renewed focus, particularly on speed reduction as a countermeasure, which focuses on traffic calming measures, how to reduce traffic volumes on local streets and reduce risk, looking at different kinds of pedestrian and bicycling crossing facilities, things like current traffic calming measures and best practice in that field as well. Can you switch to the next slide as well to cover the remaining? And other things that are built into the Safe Road Investment Plan, such as minimum length and spacing and the rules that work in there. We're looking at a range of new countermeasures, if appropriate, and looking at how those things get triggered and the hierarchy rules that apply to them as well. So all of these will be considered over the next few months, and we will be working out exactly how we address each of these things. And then that next phase of the project, as Kate mentioned, we'll be moving on to later this year. Next slide, please. You can flick through this one. Does anyone have any questions?
Hi, Monica. We have one question. Actually, this question came earlier, but before your presentation, but I think you are the right person to answer as well. So are there attempts to consider incorporating driver behavior models to star rating models so that we can obtain star ratings that factor driver risks?
Yeah, this is a really good question because, and it's one that I think Jeremy touched on in the previous presentation as well, about the role of road users themselves in the system and understanding that more deeply. There's certainly a lot of emerging research around the interaction between road design and the signals that feeds back to road users themselves, even things like perception of speed and how we are designing roads that essentially allow people to go much faster. I mean, we all know how it feels from those like rare occasions when you get out of your car on the highway and you realize that everything is 10 times bigger when you're standing on the side of the road versus when you're actually in your vehicle. And it's really important about how future road design, particularly for urban areas, make sure it is shaped far more for to sort of influence the road user behaviour. So there are, there's enormous connections between the two. Whether it's going to be incorporated in our model explicitly in any time in the near future, probably not. We're going to have to wait for this field of research to emerge more. But I think over time we will see more things emerging, and I think long term, yes, I think that's possible.
Thanks, Monica. We have to move on. We are a bit late, so we'll keep the presentations and with the questions, but I will ask a little bit more of your time. We may pass another 10 minutes. And now we have Sam Hansen from Warwickshire Safety Council presenting Road Authority route reviews. The mic is yours, Sam.
Thank you. Good afternoon all. I'm Sam Hansen from Warwickshire County Council. I work in the road safety engineering team. So I'm responsible for analysing collision data and developing safety engineering schemes. We're very much new to all of this, so we've just started our journey with the Road Safety Foundation and the risk mapping process. We've just finished using it on one route within Warwickshire. So I'm here to talk about my experience with the software, some of the things that I found useful for our highway authority. The route we've chosen to do it on is the Foss Way, which is a really straight road. It's a very rural route running between the A5 and to a rural area in Gloucestershire for a distance of 59 kilometres. It's a very mixed use road. We get a lot of motorcyclists and leisure users trying to access the Cotswolds, but it's also a very important HGV route for deliveries and industry located along the route. It mainly links small villages together as well, so it's important for them to get between the nearby towns and where they get their facilities or work or something like that. So it's always suffered a very poor collision record. The main reason we've chosen to do the exercise is that the Foss Way itself is affected by the UK's high-speed rail project, which cuts across it. And as an authority, we would have concerns with the increasing construction traffic that brings and the effect on an already existing poor safety record. So what we wanted to achieve out of it is an insight as to where the locations of increased risk are, to which specific user groups, and to explore engineering solutions that could improve the safety along the route. Next slide, please. So the existing results show that the route is generally of quite poor rating to all user groups. Just 3 kilometres out of the 59 kilometres of the route is rated as 2-star above for vehicle occupants. So it just shows that we have work to do to improve the route. Our traditional methods for collision reduction and engineering schemes would be to review the collision data individually, manually, by engineers one by one, with engineers looking for trends and patterns between the individual records. So the process for us allowed us to understand where the risk is along our routes, and it challenges that traditional method of collision investigation and reacting to clusters of historic collisions or strings of cluster sites, and actually allows us to look at the risk and be proactive along the route. And it also, along with that, can bring with it increased accuracy, and obviously it's a big time saving for us because we don't need to individually look through each collision. So we found it quite useful. So next slide, please. My particular favourite tool is the risk worm, which it basically shows the risk of collision along the study route. So the higher the number or the score on the y-axis is the higher the risk of collision. And then as you move along the distance on the x-axis, the map on the right also follows where you are, and it shows you where along the route the particular areas of high risk are. I particularly like the map because in the case of the Fossway for us, it's a very rural environment with nothing really marking points along it. So you can actually see where the risk is without trying to find it out on site. So it saved us a lot of time from manual methods, basically. And the risk worm breaks down what the particular risk is at the various locations, which enables us to tailor safety engineering solutions with the aim of targeting specific risks to specific user groups. So on our route here, we can see that at various points along the Fossway, there's peaks of risk, basically, which are highlighted in pink. And they are junctions or intersections that cross the Fossway. So it quickly gives us a visual thing that we can look at for the whole route and say, actually, our areas of risk and probably our areas of focus should be the junctions along the route. So for this route in particular, we have 150 individual collision records. So by being able to visually see this in one chart, it just saves us a massive amount of time and obviously money in terms of labour for engineers actually doing the work. So we found that really useful for our route work. Next slide, please. So another useful tool is the UDIP process. So I think it's been touched on, but it shows us what the software has considered as potential treatment measures in 100-metre sections. So I found this really good because it enables us to build in our local knowledge of the route and to put in suggestions for engineering measures and look at the impact that it might have upon collision risk. So we've used it, and it's been very valuable to us because we can say, actually, we'd like to see between this point and this point, we'd like to lower the speed limit and install traffic speed cameras, and to see what effect that has on collision numbers and collision risk without actually doing any construction works. And I think by doing this virtual testing process, it allows us to select measures that are the best solution for the location, but without the actual cost of investigating it. We found that really useful in our bid writing for funding, in that we can provide data rather than estimates. So I think traditionally, like an engineer would estimate, oh, I think I could probably reduce collision numbers by this amount by doing this. Whereas actually we can provide the risk worm and the expected star rating within our bids to say, actually, this is the best thing for the location, and we can demonstrate a benefit here. And in our case, we've used it for the high-speed rail project, in that as part of their construction works, they'll be changing the Fossway. So they'll be constructing roundabouts and changing junctions in order to do their construction works. And it's allowed us to see the impact that they're having on our risk, and where it's a detrimental impact on our risk, to provide a case for funding in order to provide a safety scheme or make changes to their scheme to make that risk reduce. Next slide, please. So for long-term development of the route, the tools provide an investment plan which provides engineering recommendations and their estimated costs to improve the star rating along the road and provide the expected financial returns as a result of preventing the injury collisions. So that is useful to us as it gives us a long-term aspiration for the route, and it acts as something that we strive towards achieving. So it enables us to quickly seize opportunities to present themselves and have ideas on the shelf ready to go. So if the funding opportunity or Department for Transport funding is available, then instead of thinking, oh, what could we do, we already have a list of things that are ready. So it's quite good in terms of time efficiency for us. And it's also a very good tool for road safety partnerships and discussions with local politicians, because we can say, well, actually, if the funding was available, we could do this. So instead of just saying we think we've got a scheme here, there's actually data that we can provide and share and communicate with people that says this is actually worth doing. We need to do safety schemes, and there needs to be the funding available to do it. So it's quite good in terms of marketing, actually. I think that's been very useful to us. So just on this project alone, we've used the exercise to obtain funding for signage schemes for crossroads throughout the route. So I think we've got 4 or 5 signage schemes we're doing now. We're installing a protected right turn lane on one of the junctions, and then we're converting in an existing junction from 4-arm to a 3-arm T-junction. But on a wider note, it's also let us see the impact on major schemes, such as changing the road layout to a compact roundabout or traffic signals to replace junctions in their entirety, and that's leading us to investigate these further, as they can have a significant reduction in the risk. And actually, whilst they are a lot of money, the return is easily demonstrated, and they do offer very good rates of return. So in the future, after doing our project, I think we are looking to expand the mapping to our major route network within the county so that we can monitor our routes year on year, and create an action plan to improve these routes over time. And I think overall we will be shifting from that traditional methods which were mentioned, where we are very reactive to cluster sites and to places where accidents are happening, to a more proactive approach where we're looking at where the risk is and where we can be proactive and deliver a scheme and look towards a safe systems approach and Vision Zero. So I think this is what is seen by us as a tool to enable us to do that. So that's it for me. But any questions, please feel free.
Thanks, Sam. We don't have any questions now. If other questions come, we can ask later.
Okay.
Thank you so much for the presentation. And our next presentation is using telematics speed data in iRAP surveys with Sam Chapman from the FLU and Susie Charman from Road Safety Foundation. So the mic is yours, Sam. Another Sam.
Okay, thank you very much. So I'm Sam Chapman from the FLU. I'll tell you a little bit more about who I am and why I'm talking to you later on. First of all, just for those that probably most of you are aware, is obviously road assessment programs rely on accurate, accredited coding data to help inform assessments so that they can accurately understand risk. The most accurate data gives you the best impression and understanding of where risk lies. Now, most of these are infrastructural, but some of them are behavioural. As mentioned in the last round of questions, was that some aspects of behaviour are already within the models, so things like operating speed are there. And this is a key factor, because if you travel very slow through an area that's of higher risk, there is less risk overall than someone travelling very fast through that same environment, of course. So next slide, please. So with road assessment programs, speed is actually really quite key to not necessarily understand the level of risk, but the mitigations that you want to employ to actually transform that risk and to come up with the most appropriate suggestions for the mitigations that you wish to place on the road network. Now, traditionally along routes, operational speeds have been sourced via fixed point measurement, range measurements, assumptions, or traffic models that are applied across the network from limited monitoring points, so from existing fixed cameras or inductive sensors as shown in these images. Next slide, please. What this means is that fixed point monitoring, where that information is taken about a particular route, you'll have a fixed speed at that point. So there'll be one speed from that point applied to a broader section of the road. The same for the range monitoring. Within 2 periods of monitoring, there will be a speed applied to that section of road, which is an average of the speeds that are exhibited over it. If we go to the next slide, the reality of this is often far different, whereby you can see here a more typical behavior in terms of speeds, with the red being faster, the green being slower, which shows a more granular change of speeds that's operated on by the vehicles that travel down a road. So the fixed speed monitoring in this instance would have the higher red speed applied, which may have been inappropriate for the junction and the corner in particular. The green, of course, would take an average value between the orange and the green, somewhere in the mid-range between that for that section, which again isn't necessarily the most accurate fully down that route. Next slide, please. Now, you can get accurate information, of course, related to speeds, but it can be very costly if you wish to do fixed point monitoring at every section and every section of the road in order to determine speeds on every part of it. Now, this can be done in alternative ways, and we'll talk about that in a minute. But when you do apply these the more accurate speed measurements across a road, you end up with a pattern of behavior whereby vehicles slow down around certain junctions, where there's certain infrastructural components where they either perceive more risk or a potential of someone coming from a side road or another type of obstacle, whereby the risk needs a differential modeling. The important thing is that we will try to get the most accurate source of information into road assessment programs to give the best output and risk understanding possible. Next slide. So how do we increase the quality of the speed data without increasing costs? Because obviously increasing a very large number of traffic surveys and speed surveys would be counterproductive in terms of the delivery of effective costed projects for safety management. So the methodology for this, if we go to the next slide, is to utilize new data sources. And one of these is something that I have a specialism in terms of telematics data. Now, you may see from the image at the right, a few points moving around from vehicles that are traced as moving around out of a particular parking space, for example. And in this instance, you'll see that some of them head out very fast, some of them head out very slow. There's a whole series of different behaviors that can be observed there. What you can do is you can take this information, you can aggregate it and use it to understand the patterns of behavior to come up with what is a more accurate 50th and 85th percentile speeds, which are the information that goes into the existing model as it stands, that can provide information on every section of road down to a very fine granularity. Next slide, please. Now, this information is available more and more frequently as more and more tracked vehicles exist on the road. Now, currently there are billions and billions of miles of data gathered daily in terms of tracked vehicles that will be gathering information, providing insight about the behavior on the road at individual points. And these can provide insight on all parts of the road network. On the map to the top left, you'll see an area of the map that is blue, which is the areas where the company I work for has telematics data available, which will cover the entire road network with information about the behavior of vehicles on them. The red areas, not so much, but we do still have some data in those areas as well. Now, these data sources can obviously help to inform and give a better picture of where risk lies. If we go to the next image, next slide. What this means, if you apply these without changing any other factors that go into risk models, it changes the risk worm along routes. By giving a more accurate speed at the very precise intervals over the course of a journey, it differentiates the level of risk that can be seen at different areas, which can then change, of course, the mitigations to a small degree for the most appropriate ones that are useful for making roads better and safer. So you can see here the telematic speeds in blue, which are taken from a whole series of vehicles gathered over a long period of time to come up with what is the normalized patterns of how people drive, fed into the risk models. The risk models then generate for the first portion of this journey, in the first 1,000 meters or so, have a higher level of risk than the traditional method, as where the last 1,000 meters here, the telematic speeds indicate it's actually it's more safe than the model predicts. So there is some deviation that can occur along routes because of those changes in speeds, because of taking the assumptions from traditional speed models and applying them on roads. So the more accurate the speed data you can put into risk models and road assessment programs, the more accurate mitigations you get out of them. Now, the road risk and star rating levels vary slightly, but they don't vary too much. It's more the mitigations that change, the recommendations that come out of these systems that help to inform better how to minimize those risks. Next slide, please. Now, this, as I just said, this refines the countermeasures presented, and ultimately this gives new ways to be able to present information. Now, data may not always be as easy to obtain in some parts of the world, and there's obviously new ways to do this, and we've done this in various parts of the world in different ways. This is an example from Ireland, whereby all the roads around Dublin were changed to new speed limits, for example. We've released an application that gathered data from a large number of citizens to basically monitor the changes both before, during and after the mitigations are put in place to see the effectiveness of the change of the technology, the change of the infrastructure. Now, this allowed this information to be looked at to see and judge the effectiveness, but at a very low cost, rather than a traditional methodology of monitoring speeds at each and every one of the locations, both before and after. This allowed a record to be able to be applied to be able to see the effectiveness of those technologies. So this is possible to deploy anywhere where there's a capability to be able to deploy new means of data collection. Next slide. I think Susie has a few words to add.
Hi, thanks so much, Sam. It's been really helpful. I just wanted to chip in at this point and say that stumbling across Sam's amazing data has been really revolutionary for RSF and the road assessments that we've been involved in. And for the last 6 months or so, all of the surveys that we've done have involved telematics speed data. And it's just so informative. You can see on the graph in the slide, we've got the actual posted speeds in blue. We've got the 85th percentile speeds in orange and the mean speeds in sort of a silvery grey colour. And it just gives us so much rich information all by itself, irrespective of the iRAP survey, about the route and how people are using it and where there might be some issues with compliance. For example, at the rightmost end, we can see that the 85th percentile speeds are heading way above the speed limit on the dual carriageway section. So we know that in terms of the rest of the route, the compliance is pretty good, apart from a little bit of the 40 mile per hour sections at the beginning. So it gives us another strategy to take to the route for its treatment. Once you then combine it in with the other iRAP data and put it into the model, we then start to find that it really, really helps us to refine our understanding of risk, particularly for junctions and bends. And it sort of helps us to unmask the true picture of the route, if you like. Whereas when we were applying traditional methods, we were applying an 85th and 50th percentile speed to the whole route, pretty much. And that was actually not giving us that sort of really detailed information that we needed to explore risk and treat risk as effectively as we can. And obviously with the triggering of countermeasures, it means that the countermeasures can be reserved for the places that really need it the most, rather than places where actually our speed surveys were masking the true picture. And so I'd really advocate for anybody who's looking at this to explore what data they can access that are like this to inform their road assessment programs. And if anybody's got any questions going forward, then please just do ask.
We don't have any questions at the moment. I think we can move on. Thanks, Sam. Thanks, Susie. And our next presentation, and last, but very important as well, is designing safer roads through the iRAP star rating assessment with Chris Furneaux from iRAP and James Bradford from iRAP. So Chris and James, the mic is yours.
Thank you very much. Can you hear me, Alexandra?
Yes, perfect.
Brilliant, brilliant. So what we're going to do, Chris and I are going to start from the point of what's the context of this and why is considering road design so important. It ultimately all comes back to and weaves into with the Sustainable Development Goals. especially target 3.6 and target 11.2, and it's about halving those road desks. It is such a big problem. So in response to these Sustainable Development Goals, the UN actually put out its road safety targets. So if we jump onto the next slide, please. So the key ones for us, you can see they're all in different colours, but the ones we're focusing on is the orange ones, which are the infrastructure ones. And this goes out into two fields. One is target 4 that focuses on existing roads that are out there. And if you look at the tracking for this, you'll certainly see the iRAP star rating mentioned in there. But for the target 3, which is particularly relevant, you can see that down the bottom is a 3-star or better for brand new roads. And this really reflects how things are designed and how things are made, certainly in the manufacturing industry, has shifted a lot into build it right first time, build it so that you don't then have to go and retrofit when there are mistakes or stuff, especially because retrofitting typically in the road safety terms will cost 10 times the price to put, say, a safety barrier in afterwards rather than doing it when it was designed. So if we jump onto the next slide, the whole context with star rating for designs is it's not one solution, but it reflects that with the existing star rating collection, you have different suppliers who might collect it in slightly different ways, whether that's with a van going down the road or whether it's using street view data or something similar to that. And certainly with designs, it's that same kind of process that, yes, we've developed the Star for Designs web app to cater for one audience, but certainly we know a lot of other people who are actually doing this kind of thing using Excel and just working straight with an upload file. Or in Qatar, they actually built a plugin for Autodesk that was able to record the road features. And so the primary thing is about having that feedback loop. So before you've actually gone out and actually built anything, you can say, what is the safety level going to be on my road? So you don't open it and then wait for 3 years for the crash data to happen and go, actually, we missed a trick there. So if I pass on to Chris, who will actually expand about how's this practically been working with iRAP and the work they've been doing.
Thanks, James. So just to introduce myself very quickly, I'm iRAP's UK Highway Engineering Skill Leader, and part of my role is about how we plan our own internal investment in terms of research, development, innovation. And equally, to provide a quick introduction to iRAP, for those that may not have worked with us or come across us, we're an independently owned design firm, consultancy firm. And the interesting thing that sits behind that is we have these 6 aims of the firm, and these very strongly align back to elements around the Sustainable Development Goals agenda that James has already mentioned, and the road safety agenda within that. And that ownership that we have allows us then to choose slightly more independently how we invest our own funding in looking at different solutions or different approaches. So moving on to the next slide, this leads us into actually then how do we take some of these higher level policy thinkings around the SDGs and other aspects and actually start embedding it into the projects we're delivering. So we've developed something called outcome-led design, which is aimed at being this touch point between some of these higher level agendas and actually what we do on our design projects or other projects we're delivering for clients. And that's all with a sort of a mantra around sustainable development, a complete total design, and ultimately sort of delivering more from roads, not necessarily more roads, but more from the roads we've got and the interventions we choose. So the next slide then builds us into how that actually relates in a road safety context. And this is where it became quite interesting looking at the linkages between the different aspects of those high level policies from the SDGs through into the targets and the decade of action pillars that James has already outlined. But that gave us a very tangible route as an organisation to look at what we could do as across all our business in terms of improving road safety. So the slide 4, the next slide, Susie. This took us back to, well, actually let's use the safe system model for a moment as an organisation and think about what we do across the whole aspect of the safe system model. And it showed a lot of good things as an organisation we are doing, but then we took the view that actually we too often will design roads and infrastructure to be compliant with standard, and actually what can we do to make schemes as safe as they can be, and that led us through into the star rating, and then ultimately star rating for design. So we've now been testing it on a number of schemes. We've tested it on about half a dozen schemes within the UK, coding schemes at the design stage to really test the tool, understand what it's telling us, and the benefits that it can bring to the projects. If we move on to the next slide, we can share with you some of those highlights and sort of aspects we found through that process. So I guess at the first stage, you can, where relevant within organizations, you can provide that tick that you've delivered 3-star or better designs, which is a really important thing. And I think a number of presenters earlier mentioned the ease of understanding and almost the marketing benefit that can provide. But more interestingly, the risk worms on the right show 2 different design options for the same scheme, and they were broadly designed to standard. There isn't a scheme there that is sort of not compliant and couldn't be delivered. But the 2 options show a very different level of risk associated with, in this case, a particular junction that couldn't be removed when a lower gradient was provided, but by steepening the gradient slightly, it allowed us to remove that junction, and therefore actually allowed us to aspire to a design that was better, it was safer, even though it may have technically sort of, both of them would have complied with standard and delivered a sort of compliant scheme. So it allows us to challenge designers, challenge the assumptions we make, and make better decisions about what's the safest scheme. The other element that we've been looking at is how we use the FSI estimation to provide some level of verification and articulation of the safety benefits. So in this case, we've looked at the FSI estimation of the existing road, and then run the model to look at the FSI estimation of the design. And that gives us a figure on an annual basis where we can understand not just the reduction in risk, but actually how that could transpire through into reductions in fatal and serious injuries. So moving on to the next slide, the testing we've done, we've been looking at actually what does that mean in terms of use cases across broadly 2 different stages of projects. The first is around the earlier stage, sort of feasibility and optioneering type stages, and the second one being more in the preliminary and detailed design stages. And we've identified 7 broad areas where we think there is the varying levels of value cases, and the first 3 or 4 are very much around design decisions. So using the demonstrator tool at an early stage to test cross sections or standard details to understand, are they going to provide limitations to the star rating you could achieve. The next couple, corridor and option comparison and departures from standard reviews, allow you to articulate the different risk profiles of options and actually choose the best option for the scheme, considering the wider constraints that may be there. The final one is, the 4th one down, design improvement opportunities, is using the interventions to actually see, are there things we can do to improve the design beyond what we sort of set out at the starting point. And then the final 3 are more of an articulating the value case and the benefits. So providing that full star rating for design, so you've got it clearly articulated. Looking much broader at what the customer, the wider road user experiences. How is the experience for motorcyclists or pedestrians or cyclists? And then the final one is a sense check around, are the economic benefits broadly as we would expect for the scheme? And in some cases, it may be that the forecast FSIs allow us to provide a stronger case than a more traditional case may have provided. So the final slide, just to summarize, this isn't around, in my view, removing any of the tools we currently use in the design process. Design standards, good practice and sort of best practice and road safety audits are all a really strong and rigorous part of the process. but the star rating does provide a different tool to the design teams and allows them to challenge some of those traditional decisions. So the key benefits that we've identified so far is around quantifying risk of different options. That example I showed you earlier, being able to make a decision in a clear way, understanding the risk and not just qualitative views around the road safety impact. Clearly highlighting risks for all road users to designers. We started out looking at star rating for vehicle occupant, and you might find you have 3-star and you sort of go tick, great. But actually, when you look at it for a motorcyclist, you've only got 1 star. And although they may be a relatively low number of road users, we need to focus on all of them if we're going to really pull down the people injured and killed on roads. The third point, it allows us to challenge improvements to the design that comply with standards. So actually, how can you go above and beyond the minimum baseline in standards? And then the final 2, Sam's presentation earlier touched quite heavily on designs on speeds, and that's a really interesting point when you get into the design space and you haven't got operating speed. You're making assumptions about the difference between speed limit, operating speed, and design speeds, and what you can do to better encourage or enforce lower speeds. And then the final one is it does provide an independent verification or rating. It provides something there that people can understand and is quantifiable and consistent across a region, a country, or the globe. So I think the final slide is just if there's any questions.
Thanks, Chris and James, for your presentation. We don't have any questions now, but thanks for your presentation. If it comes later, we will share with everyone on our website. Thank you so much. And I also want to share Susie's contact here, email, in case you want to know more about these projects that were presented today. Susie is available to answer any questions, or if you want to know about what they are doing. So this is her email. And next slide, please. So just a final quick reminder of some of the resources that are available for you. iRAP has 5 websites. Some of them were mentioned during these presentations today. So feel free to use this resource. They are free for you. And also on the next slide, please. And also iRAP offers training for professionals that want to perform iRAP methodology. Here are the topics that we offer online. Some of them are in different languages, and you can see more information on the link available for you there on the screen. On next slide, please. And please stay on the line to answer a brief feedback about this webinar. We would love to hear your opinion, your feedback, what you've thought of today, and what other topics that you would like to see in these meetings. So when you finish the webinar, there will be a pop-up screen for you to answer the form. And again, I just want to remind you that you receive an email tomorrow with the link to access the video and the presentation of this webinar. Please let me know if you don't receive, and I am happy to share again. But it will be on our website, all this information. And last slide, and finally, just heading to the end of this webinar, I want to thank everyone for attending the RAP Program Leads Coffee and Connect meeting. And thanks for your participation and questions. Thanks to our presenters for taking the time to present your project experience, plans to use iRAP methodology. It's really great to see the experience of what has been happening in UK in terms of the applications of iRAP methodology. So thanks, and we'll see you next time soon.